Hey everyone, how's it going? Sorry I'm a bit late tonight, just had a couple things holding me up. So, yeah, I missed Monday night stream because it's Canadian Thanksgiving. It was Canadian Thanksgiving this past weekend, so I just wanted to take that time off. We get the Monday off here in Canada, so just want to check. Okay. Right, so where was I? Let's see if I did anything. Nope, nothing in here. So yeah, I believe last time when I was working on this last week, we were working on getting the CPU to be more accurate. So if we run it, okay, so if we run the emulator here with Mindstorm, this is the problem. Like, for some reason, all the mines end up kind of lining up like this. Not all of them, but most of them. And they all end up moving in the same direction. So I'm guessing that this is just one of my CPU instructions not implemented correctly. And I believe last time when we left off, we even had a trace. I'm going to look at the diffs. We actually had a trace that showed possibly which CPU instruction it is that's not implemented correctly. So let's take a look at that. Does it debug? Yeah, here. Probably these two here. Okay, so here's the diff between my CPU and the Vectrex CPU. Ah, yes. I'm gonna hide the minor differences and just let it focus on the major ones. So the minor difference that keeps showing up, if I just go put that back, is the fact that the Vectrex CPU, as we saw last stream, sets the half carry. It enables it in cases where I don't enable it, and these are for instructions where it says, you know, either it's because its initial state is high and mine is not. I find it weird to have the half carry enabled, but a lot of instructions don't specify what happens to the half carry, so I suppose it doesn't really matter until it matters. Like, for example, this instruction here, add A, is add sets the half carries. We can see that where it mattered, we both set it. But then where it didn't matter again, let's say over here, in compare A, mine remained low, whereas his turned high. I mean, just to like totally validate that, like compare A, if we go look at here, compare A here, or was it in here? I think it was in here. Compare A. Undefined, right? So in my case, undefined, it just meant for me, just leave it alone. Whereas in Vectrex, it looks like when it's undefined, he sets it. So I mean, I guess it's just an implementation detail. It's a choice, but it does mean that we get diffs. At least they're considered minor, but they are diffs. Now, if I hide those and we focus on where the real differences are, yes, that's it. So after running a bunch of instructions, we get to the point where what happens here? Yeah, we can see that at the same instructions where we load into A, the value at x plus 1, which is the same in both cases. At this point, it evaluates to address C87E. On my side, it's got the value 0, and oh yeah, that's right. And on the Vectrex side, it has the value 1. Now this corresponds to the Vec random seed. And that's it. Last stream when I was looking at this, I was saying that there's possibly something wrong with the way the random seed gets computed on my CPU, and it would kind of make sense that this is related to randomness, because where those stars get positioned and in which direction the mines start moving probably are using the random seed, and I'm probably not computing it correctly on my side. So let's see if we can't figure out what's going on there. So I'm going to start by looking at the BIOS. Yes, and I remember this init OS RAM, which is fairly early on when we start booting up. There is a point where we mess around with the Vec random seed here. So actually I'm curious what other instructions played with the random seed. So it's not the first time we actually load up the random seed. Here is a place where we loaded it up and it had value 0. And then it continued to have 0 through all these instructions here. Oh, see, actually mine had 2 here, just like Vectrex. Interesting. And then 0 again here. '87E. Let's go back up. And in fact, it's 2 bytes, right? We see 87E and 87F as the next one here. So these are rotate lefts, but of course if the value is 0, the rotate left won't do anything. So far that's why we're matching. But I'm sure that one point this value is supposed to become 1, and that's where we're not matching. So let's see where that happens. We're getting very close to the diff. Okay, so here, see, it's weird. Why did it get the value 1 on Vectrex here? So one thing we can do is we can put a trace point on that address and see when it gets written to. So that will help us to find, you know, the instruction that actually modifies it to 1 and hone in on the problem here. So let's enable the Vectrex implementation. Go take a look at my input. Here. So we'll try it like this. This is built now. Let's load symbols. And what is it again? It's oh yeah, it's a watch point, a right watch point. So that's what watch does. And we'll just set a watch on the address we're interested in, which is C87E. So let's watch for writes to this guy and continue. Okay, so the watch point got hit here. See, and that would make sense, right? It's about to start putting out stars. So watch point hit at C87E. So where are we? We're at F52A. Here. So here, so I mean, there's probably a few of these. Let's see if there's more than one. Yeah. So one of these, where are we? Here. Okay, well actually, so this one's actually too late. Did this actually write a value other than 0 into there? Let's see. I think it's read. No, print. Okay, so it got a 0 written there. C87E. Okay, so maybe we're going to get a few of these writes of 0, because if we look at that instruction, F52A, in fact, I think what's actually happening is it's not this guy, but it's the one before it, because we're hitting the watch point after the instruction executed, right? So really it's F52.8 here, where the roll left of x plus 1, which is that address we're watching here, got executed, right? So that would be a few times. In fact, we expect it to happen 1, 2, 3, 4, 5, 6, 7, 8, probably 8 times before we actually get a value in it. So let's just continue and see what happens. So there's another one, and we print it, still 0. And there's a 1. So it's very interesting. Let's see if how many times this happened, right? So watch point hit. So 1, 2, 3, 4, 5, 6, 7, 8. So it's exactly what I said. So on the 8th time, there was a write of value 1 in there. Ah, okay, I think I understand. This is actually 3 bytes. I think it's because it's supposed to be 3 bytes actually, and it's shifting all 3 bytes together. Let me go see. right? Yeah, pointer to 3-byte random number, C87D. So really, actually, the question is, what's going on with this random seed at C87D? And most likely what's happening is that my rotate left isn't doing the right thing with regards to the carry being set. That's almost certainly the case here. I'm guessing that the previous roll, rotate left, if the high bit gets rolled out into carry, the next one should be bringing in the carry into the low. So we'll take a look at that. But one thing that kind of surprising is, this became 0 here. Let's see. Was it ever non-zero in the at F526? There it is. 1, 2, 4, 8. Yeah, as you can see there, it's shifting. So it's exactly what I was saying. When it was 8-0, there was a high bit set. This shift left afterwards should have set the carry. So there, that's most likely our bug. So let's go take a look. CPU. Op-roll. So there's the carry. Okay, well, ostensibly I'm doing the carry. In fact, we can even look at the carry flag and see what's going on, right? Okay, so after executing this instruction, is carry set? Interesting. Okay. The reason I'm not seeing it is because I'm ignoring this so-called minor differences, but they're actually... Oh no, wait, they're not set. It's not set here. Rotate left. So beforehand it was 80, because here actually we print the value before we do anything. Oh no, sorry, and then there's the carry set. It's confusing because now my debugger will print out, before executing the instruction, it prints out everything all the way up until here, and then after that it prints out the rest of the line after executing it. So I should probably put some kind of like separator, or put like post or something, you know, to say, hey, from here on in, this part of the trace happens after the execute, and it's really important that, right? Because it means like here we know that before we executed, that memory cell had 80 in it. After execution, it won't have it anymore, and the carry flag got set. Now it got set for Vectrex, but not for me. So right there, that's a bug, right? That's the bug actually. So why didn't it get set? Again, keep having this problem. I really gotta check all the places where I do this. See, even here. Really what I should be doing is I should stop using this and start using my functions, because I wrote a bunch of helper functions in my bit ops specifically to get around these kinds of ridiculous problems. I have a test bit, for example, which returns a bool, and I can say, you know, here, instead of doing what I was doing, I should say test bits value and then bit 7. And that there will do the right thing, because you can see what it does is it reads the bits and checks if it's not equal to 0, which is what I was missing, returning a bool. And in fact, in this case, I probably want to do test bits 0, 1, which is the one that returns 0 or 1, which is exactly what I want to do in terms of setting these bit masks. Either one will work, actually. The bool will be implicitly cast to 0 or 1, or I can be explicit about it, which is probably a better idea. Like here it should be test bits, value bits 0. For rotate right. Okay, so let's see if this works. Go back to my CPU, and hopefully this will fix our bug. Alright, partly fixed. In fact, I think now it's behaving like Vectrex. Not quite. They're all moving upwards again. Oh, these guys are moving downwards now. It looks like there's something wrong with like the initial condition. Just the fact that all the stars get distributed to the right, this comes back to like something funky, because I'm sure that now if I die, for example, or finish the level, the next round will behave more as we would expect. Or not. Oh, see? We got a few on the left side now. And let's see if now they'll move a bit more randomly. Yes. See, now they're moving more randomly. Oh, now we're getting, see, the more even spread. So there's something about, I wonder if the Vectrex is expecting that memory cell have complete garbage in it as a way to like make it a real random seed initially. I really get that impression. Does that make sense though? It looked like the BIOS was actually clearing it. But now it is working in the same way whether I use my CPU or the other one. So let's say I run the Vectrex CPU, you'll see like that, the stars do get created in the upper right corner first, and I think all the mines will move in one direction first. And then after that everything kind of fixes itself. See, this is with the other CPU as well. Again, spread in the upper right quadrant, or so. And then these guys all move upwards. And if I die, now we'll get, see, stars moving to the left and to the right. And then when they spawn, they'll start moving in all different directions. Yeah. Yeah, I have so many of these. But see, like, I have things like calc. I have a calc negative and a calc 0. I really just need to be more consistent with my usage. You know how it is. I implemented this CPU a while ago when I first started, and I wasn't quite sure in which direction I was going to go, and I just kind of kept working at it and changing it. It's like, for example, here, this really should just be calc negative, you know? Calc 0, which is down here, or up here. Calc 0 just checks if v is 0. This all should be written in terms of these functions. Okay, well, let me at least commit this fix that we have on the CPU. CPU fix op roll, or so I'll say fix roll and roar to compute carry correctly. I kind of feel like fixing some of these. At the same time, in fixing these, I might actually break something, you know? See, I have a calc negative that automatically works for 16-bit values. Just does the right thing. See, now this is a special case where when we store, what was this again? Or is this, no, sorry, is this a special case? No, it's not. This is just an 8-bit source register. Yes, this is totally fine. Okay. Now we have special cases here. I mean, most of them are written in terms of my helper functions. I think it's just some of the older instructions where I didn't do it. Like, what's the deal with this here? Calc carry for multiply. Why am I looking specifically that bit 7 is set here? Right. So actually this would work because the idea here is A and B are 8 bits. That's why I did it this way. I should be using calc carry for the multiply. Because what I do is, I know that I'm taking two 8-bit values and I store the result in a 16-bit. And then the calc carry for 16 is making the assumption that it was for 8-bit multiply. So just checking, are any of the bits in the upper the high 2 bytes here set. Now here, although here what I'm doing is I'm checking if the results bit 7 is set. Really? That makes sense. Set if accumulator B's bit 7 of result is set. That's exactly what I did. Okay, because it's basically taking value in A times the value in B and storing it within AB. All right. Does that make sense? Carry is guaranteed to occur if bit 7 is set, because if the numbers are large enough to cause a carry, let's see. Unsigned multiply. Hey BDCW, how's it going? Just wondering if this is right. What does this book have to say about multiply? Multiply instruction performs an unsigned 8-bit by 8-bit multiplication of the contents of accumulators A and B. The result occupies the double accumulator D with a high order byte in A. In this case, we know that the result is 90 or less. Oh yeah, it's actually a bitwise multiply. It's not a decimal multiply, it's a bit multiply. Okay, that's why, because a carry would occur. Bit 7 resets C to 0. The carry flag is set to the final value of bit 7 of accumulator B, thus allowing rounding to an 8-bit result in A with the sequence. Okay, so I mean this is accurate because it's really a bitwise multiply. So this we don't touch. what I'll do is, at least for these cases, I should use my function. If I'm not going to use calc, I'll do a it'll be exactly the same here. Yeah, I think I prefer using this rather than the... You know, actually I was messing around with because bits here is my cool little macro that calls this cute little template meta function that I wrote, where you set bit positions and it produces a compile time value. So it's totally constant compile time. It's a constant that it produces with the bits set, right? So it just shifts one by the number of bits that you specify, and it ORs all the values and produces the result. Now, this works in like C++, even pre-C++ 11. But I was messing around. I don't have it with me, but I was doing this at work, of using C++ 17 with constexpr and what's it called, fold expressions and variadic templates, and I was able to write this whole thing in like 2 lines. And it's really even more expressive because I'm not bound to things like size t. In my case, what I do is I'm even able to deduce the type I should use based on the largest value that you input. So this is really neat. So I'll probably bring that in at some point, and it'll be cute. And I won't need this macro anymore because it's just all constexpr, and it's really, really cool. Yeah, this is special logic for overflow because we know we're incrementing. So we know that if we increment a value and suddenly the value is 0 after the fact, then that implies overflow. I could also have checked if you know, before we incremented, whether the value was you know, 255. It would have been the same kind of thing. This is exactly the same kind of logic. Yeah, and in fact, I had kind of gone into the habit of forwarding one call to the other for later. Yeah, like here, you know, here for the version where we read from memory, I call afterwards, after I've gotten the value, I just call the one where we typically accept a register. So I tried all kinds of different things. I wasn't completely consistent because as I was implementing the CPU, I would change the way I would implement things over time because it just made more sense. And I told myself I'd go back over it and kind of clean it up. Yeah, I think all of these now are written in that kind of method where we just forward. And it does clean it up, you know, and it gets all inlined and everything. So like in this case, in the case of, let's say, negative, this guy here, rather like op neg, here takes a uint 8. And then here, oh sorry, it's already what I'm doing here. It's not op neg I want to look at. It's here. Op increment. Right, instead of doing the same code here that I was doing up here, we call op inc, we pass it the value, and then we write back the value because it's been modified, and then all of this disappears. I actually wrote the to-do here. Well, there you go. I did what my to-do said to do. So this here, I should not write reg then. I should do what I've been doing with the other ones, which is write value, because it may be a register, it may not. So I'm so gonna break everything. I think Decrement has the same problem. So let's do it here as well. So this here will also become value. All right. Value. And this guy we'll just call op decrement. I guess I don't need to store the original value here, but we need to write back out the result. Now this calc 0, calc negative, so even though this is like a lot of changes to the CPU and I'm possibly breaking something, because I have a pretty nice test harness with the comparison against the Vectrex CPU, I should be able to nail down pretty quickly whatever mistakes I make. Because we know now that it runs pretty much the same as the Vectrex CPU, so. So this is arithmetic shift right. Calc negative. So here I'm calculating carry. What am I doing here? It's because I know we're shifting right. This is a special case again. We know a carry will have happened if the original value had a 1. Yeah, that's what this is about. And that's okay. We'll leave that alone. Okay, good. So this is the one we just fixed. So overflow here is a bit special for rotate left. So I'm going to leave this alone unless so rotate left, okay. Rotate right, looks correct. Okay, I think these are, now we're going to see that actually future instructions were written, or maybe not. I was going to say are being written in terms of these helpers I wrote, but not quite for arithmetic shift left. I can see that it's not. Negative. I should make all of these const expr just to be sure that they happen in compile time, because they all can be. Really? Delete can only appear on the first declaration of a function? Why was this fine when it wasn't const expr? Interesting. Maybe once you make const expr, Interesting. That sucks because I wanted the compile error. Well, you know, actually in the case of this one, I just won't make it const expert. Yeah, because we don't care. These are ones that we want to delete from the overload set. Yeah, that's cool. All right. Okay, that's fine. Because basically I have these versions of my functions that I delete, which is really neat because it's basically like, for example, if I look at if we look at calc carry, we want to allow it for 16-bit and 32-bit, but we don't want it for the 8-bit value, because the way I use it is that, you know, if you want to use this, the assumption is that you're going to take two 8-bit values and produce a 16-bit value, or two 16-bit values and produce a 32-bit value to then compute the carry, because I'm looking at the higher order bits of the larger type. So for 8-bit, it makes no sense to have a calc carry. So what I do is I delete the function. So if I ever make the mistake of calling this on an 8-bit value, the compiler will say, hey, this function has been deleted for this type. And then I'll realize what my mistake was. Okay, so let's keep going. This is such a complicated piece of machinery. The op exchange and the op transfer, there's such strange instructions that look at the post byte to figure out what kind of operation to do. Yeah, it's crazy. And it'll either swap or assign, depending on one of the bits again. It's nuts. Oh, and that's it. So let's see if this actually works. All right. I should probably spell it correctly. Oh, my non-lock is on. Wow, it's long to compile. With all those templates, I guess. It's alright though. In release, it really compiles out to lots of inline functions, so it's really well optimized. So apart from those like positions and the initial movements of the mines, things do seem to be working in terms of the randomness. I'm very curious about the fact that the initial positions are not in the right sector. sorry, that they all end up in kind of one side. So now we're good. Now, there's another bug that just showed up, which is at some point it looks like see here I'm constantly turning. Oh, and I stopped. It's hard to play with the keyboard, actually. Okay, so I'm gonna consider this CPU refactor perfectly fine now, even if I might be wrong. CPU, refactor opts to make use of calc helpers. So this is cool, right? It's pretty much working. I'm still curious about the fact that they cluster up in the upper right corner the first time around. I really am curious about that. Like I'm looking here, what is it trying to do here? Saying load into D the address of vecRandomSeed, then store D vecSeed pointer, what is it supposed to do? vecRandomSeed. Wait. Trying to understand what this is supposed to be doing. Load D the immediate value of vecRandomSeed. So it's gonna, I suppose, put C87D in there. Let's see. So there we are. So D is FFFF. So we step. So yeah, there's the load into D C87D. Sure enough, if we look here at the post-op, C87D, because D is A and B. And then the next instruction says store D vecSeed pointer. Make sure random number. So vecSeed pointer is C87B. Pointer to 3-byte random number seed. B, C. default 3-byte random number seed. Make sure random number seed is non-zero. Branch if equal. So this is going to keep looping until it's non-zero. That's what the next part does. Point 87b to 87d. Okay, we want to store. Okay, this is a pointer, hence the name. Okay, we're gonna store the address of the vec random seed, which is C87D, into 87B and C. Okay, now I understand. So like right now, if I print two values here, 87B and C have 3B and 3B in them for some reason. Now if we step, we've stored there those values, so now they still have that. Oh, yeah, it's my bad. C87D. Okay, so yeah, I mean, I don't know what they were before. I had not printed them correctly, but after this, the vec seed pointer does indeed point to the 3 bytes of the random seed. Now, this is the thing, right? So I think this here, vec random seed, will have all zeros because of the way my... So I'm getting the feeling like the Vectrex probably has like random garbage in memory, and it's kind of relying on that for the initial state. And it just says, well, just to be sure, I'm going to increment vec random seed, the first byte, to make sure that the first of the 3 bytes is non-zero. Yeah, that's what I think is going to happen. So let's see here. If we print that, we have 0, 0, and 0. So that's exactly right. And so the next instruction is going to increment the first of the 3. So there's 1. We still have 0 and 0 in the next 3. And then it's going to say branch if equal back to FC. And by incrementing it, it's non-zero now. So I guess the only time this would ever branch back up would be if the initial value in there was FF, in which case it would be 0 and then it would branch again and make it 1. So I guess like the goal of this is just, let's be sure the top byte is not 0. So this is saying make sure random number seed is non-zero. That's not exactly accurate, right? It's make sure the first byte of the random number seed is non-zero. Which I suppose, you know, if the other two were 0, this makes sure it's non-zero, but anyway. Now, having said that, what will be interesting here is, I think I can set values, right? Set address equals value. So it would be interesting to take these 3 and set them to really random values and see if that changes the initial like that initial state we saw. So let's say I set this one to AB. We'll set E to CD and F to 3, 8. So now we really have some random values in there. So let's see how that affects things. Ah, there we go. See how the stars got nicely spread out this time? In fact, really well spread out. So it is as I suspected. The Mindstorm is really relying on the fact that the memory cells will have some garbage values in there, and we'll use that as its like entropy for randomness. See, now they're really well distributed. These guys that chase, these mines that chase constantly there, they're pain. This guy here, see how he's chasing? He always takes the shortest path directly to you. Okay, so what does this mean? This means that if I wanted to fix this problem, I would have to have like a mode where I randomly fill in the memory with garbage values, you know? Like here, well, in fact, I purposely filled them with 0, you know? But like, if instead we did something like I'm just going to use ran for now, even though I shouldn't. What is it complaining about? Oh, right. I'm not even sure transform is the right function to use here. Is there like a fill where you can give it What's the initial thing you want to do? There's fill n, but that gives it a value. What's uninitialized fill? Copies the given value to an uninitialized memory area. What? Oh, okay. Because it does a placement new. Interesting. But not what I care about. So what's the problem here? Conversion from int to uint8? All right. So ostensibly my memory now is completely not 0. Yeah, there we go. So that's like less helpful in terms of, you know, debugging and stuff, but we can kind of maybe have two modes here where we maybe for debug purposes we can initialize to 0 to simplify to catch problems, but for the non-debug we do what we're doing now, which is fill it with random values. Let's use a uniform int distribution of uint8t. And we're going to need an engine for it. Alt random engine. So in fact, if I do this, I don't need any of this garbage. I can just say distribution of engine. I just need to capture those. So let's just capture everything. Requires one of short, int, long. Ah, I see. In that case, we will have to cast. But I can feed it a min and a max. So we can see like all this memory here. Actually, RAM doesn't map there. Memory map. So we're talking starting from C800. I was actually printing the ROM just there. So we can see like 5C, F6, EE, 79, 2C, basically a bunch of different values. Whereas if we were to skip all this, they should all be 0. Yeah. Maybe what I'll do is I'll add a function here, randomize, where I'll put this code. And then here we can decide whether or not we want to randomize RAM. Some Vectrex games, some games rely on initial random state of memory, e.g. Mindstorm. Now one thing is I haven't set a proper random seed. So in fact, maybe we'll pass a seed to randomize here. I think it's the engine that takes the seed, is it? Yeah, you can seed it. Does it not take it as its yeah, there we go. It's a Mercine Twister in this case, the default one. But I think I saw that the constructor took a seed, right? Unsigned int x0, is that the seed? I don't know what I'm supposed to do for this. Random engine set seed. Construct linear congruential engine. Yeah, so there's the one that takes a default seed. But is that specifically for... It is a library implementation selection of a generator that provides at least acceptable engine behavior for relatively casual, inexpert, and or lightweight use. The following alias is a membered type of default random engine. In the case that is a linear congruential. Like my question is, do all of them, do all the engines take as a parameter the seed? Not necessarily. So maybe it's just safest to call seed on it. Seed the engine. Unsigned int. Standard random device, eh? That's interesting. Standard random device is a uniformly distributed integer random number generator that produces non-deterministic random numbers. That's kind of cool. So use another uniformly distributed integer random generator. So another generator to see the generator. And then you create it and then invoke. Fascinating. Okay. So I have a lot of flexibility here. If I don't want to randomize at all, in which case I'll get that initial behavior we saw earlier. I could just comment those lines out. Like this. Or I can randomize, but I can seed it with 0 so that I always get the same initial state, like the same randomness, which can be very useful for debugging as well. Although, frankly, if I debug this, I'd probably just debug it with memory set to 0, so. One, two, three, with a little 4 on the bottom. And we should see the same pattern this second time around. Yeah, 1, 2, 3, and a little 4th one here. Whereas if we actually seed correctly, totally different. Interestingly, not that different, really, right? 1, 2, 3, but just don't have that 4th one. Let's see the next one. That's kind of disturbing. seems like we're getting... Oh, wait a minute. Default random... Okay, that's not right. What I wanted was random device here. I'm going to include random just because I should. I know that's included by the other header right now, but... So now we really should see something different. It was kind of strange how it looked so similar. Now we should get something truly random. There we go. So we have these little cluster of 3 over here. Totally different. Okay. So quite happy with that. So we'll say randomize RAM RAM's memory, randomize RAM since rely on initial random state of memory. Fixes initial wave of stars all going to the right in Mindstorm. Okay. So at this point, I don't think I want to dig too deep into something. I feel like just trying a few games. I know that there are a couple, like at least 1 or 2 instructions I haven't implemented yet, and I remember testing different games and finding that I was getting these unimplemented instructions. One of the games I really would love to get working is Scramble. So this is definitely one that I think is going to crap out early on because I'm missing. I think it's subtract with carry, which I've kind of been avoiding. Yeah, see, unhandled operation SBCA, subtract with carry. I think I've been avoiding this one because subtract implementations, especially with carry, are always tricky to implement correctly. I do have add with carry, of course, ADC. That's usually significantly simpler. And I have subtract here, which is calling subtract impl. And what I had done was that I had actually generalized for both normal add and add with carry to use one function, add impl, which takes in, that's it, it was taking in a third parameter, which was the carry, initial carry value. And for normal add, I just pass 0 always, and for the add with carry, I pass in the carry bit. And I probably am going to have to do something similar for the subtract implementation. Now, interestingly, subtract is written in terms of add. And indeed, it even passes in the carry set to 1. So see, this is why I was avoiding this, because I'm sure that there's going to be some issues with this. Let's take a look at subtract with carry. Alright, and it's technically a subtract with borrow, since carry with a subtraction is really a borrow. Subtracts the contents of M and the borrow in the carry flag from the contents of an 8-bit register. It shows it here that in fact it's really R plus M plus C, but M inverted and C inverted, which is what I'm doing, right? When I'm doing a subtraction, I'm taking the value that we want to subtract and I basically invert the bits, and I invert the, well, that's the thing here, I always pass 1 for carry, which is interesting and strange, right? Why did I do that again? I'm actually wondering if in the end it's going to be the same thing as this, except 1 plus carry. So it might be 2 if the carry is set. Okay, well let's at least get the code set up. So it's up, sub is being called here. Yeah, so sub with carry is not too far away. So we find that in the current document. Okay, we get this here. Right. Can't just call subtract implement. Right? Carry a set if no borrow occurs. It's so long to compile this file now. I didn't even know it was running. Okay, I don't actually expect this to work. Okay, this is Mindstorm. I just want to make sure I didn't break it. I don't think I did. Okay, so this looks like it's still working, that's fine, but it's not using that operation. So let's see if Scramble gets any further now that I ostensibly implemented subtract with carry. Oh, well, we see the title screen, so that's new. Ah, and then something went wrong. Yeah, all kinds of wrong. Okay. So no good on Scramble. I know there was another game that I wanted to try that I also had the same. Oh yes, Rip Off. Let's see if we get any further here. So we're getting reads from unmapped range. So just as a test, let's get rid of this failure and see if we can get further into Rip Off. I'm going to change these messages to be a bit more clear. Some good Final Fantasy 1 tunes. Writes to BIOS ROM not allowed. I agree. Why are you writing to BIOS ROM? This, you know what? There's something clearly wrong going on here. Because now it's trying to write to cartridge ROM. My guess is that there's some kind of infinite loop where it's just spraying through memory. So there's definitely a bug somewhere. Not sure it would be. Maybe it is related to subtract with carry. Maybe. Because in Scramble we also got an assertion about vector, like a subscript. Oh, sorry. Like an out of range. Oh, did I close? Damn it. I did. So where is it again? Source code. Oh yeah, active. Vectrex. Oh, and they had all these nice. Okay, it's alright. Build. Rel. Vectrexy. So that will launch it. And we do that, and then we say go up one to Vectrex stuff, ROMs extracted, scramble. No, not scramble. Rip off. There. I think the next error will be the subscript out of range. No, we got an illegal instruction. Interesting. I feel like I should be grouping these. Let me just group these together. I want the subtracts together and the adds together. So here I'm passing in the carry. Yeah, there's a kind of a symmetry here. The normal add passes into 0, whereas with carry it passes to carry. Normal subtract passes 0, but with carry it passes into carry. So that's symmetric. Now, is it correct? No idea. Approve error messages or illegal. CPU, I'll say implement So one thing we can try, let's see if we get further along with, let's say, rip off or scramble using the other CPU. Because we know, like, now I just put back all the error messages because I fear like those errors are the real first errors, and then after that, if we skip them, we just, you know, run into like cascading errors. So the real first error we're getting with ripoff is read from unmapped range. Like, it's unlikely that the game was trying to read from 8A80. That's just totally an unmapped range. It's inside this here. So let's try with the other CPU. So we got the same thing. That's interesting. That's very interesting, actually. So it's not a CPU problem. So then maybe this ROM really does try to read from an illegal range for some strange reason. Was it a read or a write? Yeah, it was a read. Let's put that back in just to see. Because I mean, it's possible, right? It's always possible that games do something strange that is unlikely to be useful, but on real hardware that wouldn't really cause any problems per se. And now we get that right to BIOS ROM not allowed. So this, you know, this one's always a bit tricky because the question is it writing to the BIOS ROM because ripoff would have some kind of bank switching? Oh, we got some interesting ones here now. We got some via not implemented. What is this? Via 227. Read from E. What would this be? Interrupt enable. I think it's because what I'm doing here is I'm not actually populating the interrupt enable flag correctly. Let's just see what would happen. A without handshake not implemented. Interesting. 230. So like this guy reads from these. Maybe I should make, instead of fail, I should make like warn so that it doesn't stop like that. Never quite sure. Didn't I already fix this? Oh, 347. Was that like the right version? Let's just like comment out all these failures and just see if we can get to the game. Whoa. Oh, I think it just crashed. Unknown page 0 opcode, yeah. I mean, something went really wrong here. One more time. No, it's gonna crash. There's my crash. Let's try Scramble, see what happens there. So this is responding, but now if we go, exception caught, invalid Vectrex subscript. And we're at basically at 7F in terms of which current instruction we're. This invalid vector subscript. Where are we getting this from? Instead of doing it from here, I think if I use my debugger, it will stop on when the exception gets thrown. I think because there's a space in there. There we go. So what's the problem? Trying to read an address that's not in range. Yeah, this comes back to how it seems to be reading out of cartridge space. This is a total hack, but let's just try allowing it to read out of range. I got rid of this one. Write to unmapped range. Didn't I fix this one? See, this guy is just writing all over the place. There's definitely something going on. Can't trust this. So now we're getting unknown page 0 opcodes. Yeah, there's something totally funky going on here. So this is not the way to do it. So yeah, these are two games that are definitely not working. They'll need to be debugged, basically. That's something I can work on next time. But maybe just for before I sign off, well, let's pick a game that will work. Does Clean Sweep work? This is like a Pac-Man clone. It'd be really cool if this one works, because it's actually a pretty fun game. Oh, no. Something funky going on here. Does Hyper Chase work? I mean, for sure, you know, the fact that so many games are not working tells me that there's definitely something still not right in my emulator, and it's probably the VIA chip, and there's some interaction there that I'm not doing properly. Maybe some interrupts or something that not handled correctly. See again here, unknown page, 0 opcode. Like what's going on there, right? That's just funky. I mean, I keep picking games I know that don't work, just to see, just in case they work. Does this work? This is the bike game, Tour de France. Okay, so this sort of works, but I've got that input problem. So it keeps moving to the left. There's that problem that happens in Mindstorm sometimes. There's some weird interplay with when I read input. So I haven't got the input. I guess there's still some bug in the input logic. It's too bad because it moves like crazy, because I'm constantly having to fix the fact that I'm going. Pretty cool though. Alright. I think one game that was fun, that was working, was it this one? Cosmic Chasm? Is it this one? Mission 1. Oh, what's this? I don't think I've ever played this game. Oh yeah, I heard about this game. The center part is constantly growing, and you have this map. Whoops. And you gotta like travel. This is a really cool game. You're like some kind of digging thing. I think one of the buttons must turn on the digging power. Like that. There it is. No? I'm not quite sure what I'm supposed to do. Anyway, I think I'm gonna stop here, and yeah, we'll get back to this next week. So I have a bunch of stuff I can work on. I can try to make those games like Scramble and Rip Off work. I can also focus on the VIA chip again. I have a whole bunch of stuff here that I need to fix correctly. I want to address the like move stuff out into the audio chip. Right now I have a bunch of stuff in here that really should be in the audio chip, and there should be some interaction with it. So that's what I worked on a couple weeks ago. And that might actually fix some of the problems we're having, like the input problem. By revisiting this code, I'll maybe pick up on some subtle stuff I'm not quite doing right. That, like in here, where when we read from the VIA chip at specific addresses, and based on whether the mux is enabled or not, we're, you know, if the mux is not enabled, then we're doing stuff like, you know, reading the joystick analog to set certain things like the comparator. There's something not quite right here. Like, I think the problem here is that I'm only doing the read upon the, I'm only setting the bit upon read, which means that if I let go and the game is not reading at the right time, it may think that it was never set or something. I don't know. I gotta look into it. There's probably something there, maybe with an interrupt that I haven't seen yet. This mode we're reading the PSGs. That's it. That's the sound chip, not the VIA's DAC. So this is probably wrong. Yeah. There's a lot of stuff to do in here to get this right, but we're getting close. Mindstorm seems to be working rather well, and there are other games that are working well. So slowly but surely, and of course there's also the rendering that I can work on, try and fix that up. Yeah, lots of fun stuff to go. So guys, thanks for watching, and I hope to see you guys next week. Usually I'll be streaming on Monday. So thanks, and catch you later.